It's great to be here. Are you too busy to improve? Maybe not, because you're here, right? So maybe you recognize this situation, that you have lots of work piling up and you just feel frustrated and you don't really have the time to improve. And then the boss comes in and he actually pats you on the back. Great work. You are so busy. Great. Is this really good for your company? No. Maybe it's like this. You're about to head out to battle and you don't take the time to look for other tools or weapons. So we have some suggestions here, but no, we don't have time. We have a battle to fight. So who am I? My name is Håkan Forss. I'm a lean and agile coach from Sweden. I also go by the epithet the plumber at one of my customers right now. I try to remove the blockages in their flow of work. And yes, is this the invasion? We have 3 Swedes here today to talk about lean and agile stuff. So, but yeah. I'm going to talk to you today about how we could potentially move into a state where we can have some more time for improvement and improving our business. And I will start to tell you a story about Mr. Busy Bee and his colleague, the Kata guy. They are both working in an IT organization and are the testers of a very complicated telecommunications product. This example is just one example. You can apply this to any other kind of process in your organization probably, but this example is in this context. And what we will see is they will do testing of 2 feature sets, so 2 features for this quite complicated product. And we will see some green bricks. They will represent the actual value that the testing is bringing to the organization. We will see some yellow bricks. Those will be things that they need to do to be able to do the green ones. And then we will have the red ones, which will be waiting. And they are, well, it's at least when we talk about testing and in most other things, except for maybe doing scotch and wine and things like that, waiting is not probably what we want. And then the blue ones will just indicate when the support team is helping out and coming back with the information in this case. So we will start out with Mr. Busy Bee. He starts by setting up the test environment. He spends quite a bit of time of doing that because it's complicated. He downloads the latest version of the software and all that. Then he starts the first test case. And damn, he finds a bug. He documents the bug, puts it into a ticketing system, spends quite a bit of time to doing that and sends it off. And he knows it takes some time before the support team will actually look at it because they're very busy working on other things. So he feels he has to be busy. So he stops that test case and moves off to the next one. So he has to kind of tear down the environment and start building it up again. And while he's doing that, because this takes a bit of time, the support team comes back and they say, well, that report that you gave us, we actually need a trace log from the execution so we can understand a little bit more. Yeah, fine, I will do that as soon as I'm done with the setup and I've run the test cases here, because it's take quite a bit of time to set it up, so I don't want to stop that right now. Then he runs the test case and damn, there's a bug in that feature as well. So he repeats the process. He writes a test bug report, puts it in the system, and then he switches back to the other case. He wants to get the trace request back to the support team. And while he's doing the setup for the first one, the support team comes back. We need some more kind of error logs that describes the problem in more detail. And the tester says, yeah, I will get back to you as soon as I'm generated the trace log for the first one. And he generates the trace log and ships it off, and then he moves back to the second and try to get hold of some, do the error logging for them. And he do the error logging, and now the support team comes back and they actually have a fix. So the next thing he does is that he then steps back. Let's see. He steps back and he runs the test case, and eventually it is actually done. He do the preparation work and he's done. So now feature 1 is done, and now he has to switch back and do the last thing for the second feature. Is this something that you recognize from your environment? No? So let's see about the kata guy here. He will do it a little bit differently and see what happens. So he do the preparation work, just like the BCB guy. He will do the testing, and damn, it's the same kind of scenario. He has a bug, but instead of actually writing it down, the bug report, he immediately goes to the support team and he talks to them. And while he's waiting for them to then get back, instead of start working on the second feature, he actually gets his process coach in, and they will start to do some improvement work while they're waiting for the support team. But as soon as the support team comes back, he can drop that work, and because he hasn't kind of dismantled the environment is ready to do the testing again. So he can immediately generate the trace report for them. And while he's waiting for them to do the bug fix, he gets the process coach in again, and they do some training and they do some process improvements of how they can improve their way of working. And then eventually when the support team comes back, they can immediately sit down together and they finish the test case. So then he moves over to the second test case and we repeat the process. And what we can see here is that even that he was kind of, the kata guy here, was spending quite a bit of time with his process coach, doing process improvement. They actually finished faster for both of them. How is this even possible? Well, here's the champion. Well, a bad system will beat a good person every time. That's a quote from W. Edwards Deming. And this really comes down to two different business strategies. And the two different strategies, as described by Niklas Modig and Per Åström in their very great book called This is Lean. On one axis we have resource efficiency, that is keeping yourself busy, machines and people working all the time. And on the other axis we have flow efficiency. That means that the value for the customer or the work that we need to complete, if we have very high flow efficiency, is that that work is being occupied all the time. So Mr. BCB, he's up there. He's focusing on getting fully utilized all the time. He was working all the time, as you saw. It was either yellow or green bricks all the time. On the other side, the kata guy, he was focusing on getting the test cases to a finished state as soon as possible. So he didn't focus that much on being busy himself, but keeping the work, the value for the customer, busy as much as possible. So this has been a software context. Let's take another context. So we have a steel mill. I have no idea really how a steel mill really works, but just bear with me. So the actual oven here is extremely expensive to have up and running. You have to heat it up, And if you don't use it, you have to cool it down. Takes quite a bit of time. You have to kind of clean it out. Takes quite a bit of time. And if you want to use it again, you have to heat it up again. So in a steel mill, you try to optimize to have the furnace, the oven, occupied all the time, because it's a good business decision, a business strategy. So you don't really care if there's quite a bit of finished inventory after the oven and you don't have a customer buying it, because the expense of actually having the oven up and running is greater than having some inventory in stock. And you definitely don't want the oven to run out of raw material. So you don't really care if you have a small mountain of raw materials in front. And if we take this into kind of a knowledge work setting, that means that we will have a pile of work in front of the worker, and to keep them busy, they should always have work to do. And we also need to have kind of a pile of work for the next one in line, so they will not run out of work. And that means that work getting through this system takes quite a bit of time. But everyone is very busy. If we take the other side, emergency services like the ambulance or the fire department, do we want them to be busy all the time? Probably not. If our house is starting to burn, we want the fire department to be there as soon as possible to put out the fire, right? So we don't really care if they play, as they do in Sweden, innebandy or soccer or anything like that. As soon as they get the alarm, they drop that and immediately go out and fulfill the need at the customer. Right? Do you agree? So if we put this into a kind of a knowledge work context, that would mean that we should avoid to have a queue of work in front of the worker. So as soon as work arrives, the worker is able to start working on it. And we don't want to create a queue in between workers, because then this guy here will not be able to take on that work when it arrives. So we're talking about the extremes here on this axis. And a lean approach is really about moving from a flow efficiency, from a resource efficiency focused a little bit down here and then go up through flow efficiency first thinking, and then potentially reaching nirvana. Is it hard to reach nirvana? Yeah? And in processes, especially in our processes, reaching nirvana where we'll have full flow efficiency and full resource efficiency, it's more or less impossible. But it's something to aim for. And that is what lean does. So the question is really, for you, which side would you like to operate in? Would you like to operate here? Or here? All this is really governed by 3 laws. Our processes, how our processes work, is governed by 3 laws. We have Little's law, the law of bottlenecks, which maybe not is really a law, but and then law of variation. Is that a law? There's some math and stuff like that into it. I'm definitely not an expert in this, but the client that I work for, that are working in telecommunications, they have PhD guys doing this, and they are starting to understand and apply this to their way of working. So let's dive in. Little's law. This is Stockholm. It's one of the main artery of traffic through Stockholm. If you would want to go from here up until here, would you prefer to do it when it looks like this or when it looks like this? It's actually a trick question, because we can't really tell if the cars are moving or not, because we only see a snapshot in time, but I guess you would prefer this one. So, still kind of a software example, but this applies to any type of process where you have multiple steps, refinement steps. If we want to add something into the system and we want to complete it, would you prefer to look like this or like this? And kind of on a mathematical level, the things that governs the time that takes on average to get things to the system here is Little's law. And the Little's law basically says work in process, the things that we put into the process or in the queues of the system, the average work in process through the throughput, that is the amount of things that we complete in a certain time unit, will give us the average lead time. So average work in process through average throughput will give us the average lead time. And there's some kind of caveats to when this formula actually applies to your process. But this formula applies to your processes long enough so you don't have to care about it in this lifetime if it's actually mathematically true or not. So when you come to a state when this formula doesn't apply in your way of working, well, then you probably are in retirement. So this one you can actually apply in your way of working. So just some simple math to get it. So if we have 12 things in the process, and we can process something like 12 things in a minute, the average time to get things when you add something new to the queue to get through it is 1 minute. Make sense? So if we don't change anything else about the system, the only thing we do is to lower the amount of things that we have in the system. We still produce the same amount of things. The average lead time will go down to half. And on the other side, if we double the amount of things that we have in the process, we will double the average lead time. So this will govern how you operate your processes. And when this doesn't really apply on the big picture of your process, please come and see me and we can start to get you in touch with some queuing theory PhDs guys. But it will not be in this lifetime. So if we think about projects or features or whatever, we have A, B, and C. And either we work on them in parallel or we work on them in sequence. So we will get kind of two different Gantt charts. It's kind of simplistic view. Probably this one will be even better, but I will not sugarcoat it. So in this case here, what we can see is that if we would get paid for a feature or whatever we deliver, we can actually start to get paid after 5 days instead of 15 days. And just like in most knowledge discovery kind of process, maybe it is when we put feature A and feature B out to the field, what we discover is that we have actually fulfilled the needs of the customer, so we don't actually need feature C. So in this scenario here, we can find that out. But in this scenario, we will have to borrow money for much longer until we get paid, and we don't have the opportunity to test and see if we actually need to do all of it. So my advice is look at how many things you have in process and focus on the things that is most important for you. Let's dive into law number 2, the law of bottlenecks. And we will then step back to traffic again. So every process have a bottleneck somewhere. It's either in the process itself or it's outside in the bigger system. But it has a bottleneck. And just like in traffic, especially if you go in rush hour in Stockholm, we know where the bottlenecks in that system is currently. And you can't actually go faster than your bottleneck. On average, if you look at the process and the big picture of the process, you can never go faster than the amount of things that can go through the bottleneck. So if your throughput of the system or the capacity at your bottleneck is 4, if you have excess capacity in front and excess capacity after the bottleneck, you will still only have a throughput in this based on the throughput at the bottleneck. And as long as you have as much capacity or bigger in front of your system, in front of your bottleneck, you can run as fast as your bottleneck. If you have less, of course, the bottleneck might move that way. But if you use the full capacity in front of your bottleneck, what only happens is that you will slow down the system. You remember Little's law? The more things we put in the process, the lead time goes up. So the only thing that will happen is that the cars coming in here, if we are using this to full capacity, will just take longer and longer until it actually gets out. So what we want to do is to run it close to the capacity that we have at the bottleneck. And on the opposite side, as long as we have equal or bigger capacity after the bottleneck, we can go as fast as the bottleneck. But it doesn't. We can't actually make the process go much faster. We can't make it go faster than the bottleneck, at least not over a long period of time. So if the bottleneck is very upstream, if you add a lot of capacity at the end, what only will happen is that you will actually empty the system. It's just like the feeling when you go through the bottleneck on the highway, and eventually you can see, well, where did all the cars go? And that's the same feeling that you will have in the system if you have a lot of spare capacity after the bottleneck. But it has to have to be a little bit bigger than a bottleneck, of course. Then we go to the third law, the law of variation. So we step back to this model again, and kind of one of the things that will kind of stop you reaching nirvana is variation. And that variation would be arrival rate. Are the cars coming at the same rate onto the highway, or are they the similar size, or can they accelerate and brake in the same kind of same manner? So the higher the variation, the harder it will become to reach nirvana. So this is a low variation situation, and if we raise the variation, it will be harder and harder to get closer to nirvana. And there's some formulas that can prove this. I think it's called the Kingman's formula, one of them. And it says the higher you utilize your system, the higher resource efficiency you have, the lead time will go up. So if we don't change anything else, but we have a stable system, but we have a low variation. When we get close to full utilization, you will see this kind of curve. But if we have high variation in the system, that curve will go up much faster. And the people here in the audience, do you do product development? Software and product? Are you doing anything else? Manufacturing? So I guess there could potentially be software and product development is a little bit higher in variability. Manufacturing is a little bit lower. But the same kind of thing apply. It just apply in different ways. So to get to very close to nirvana, manufacturing could potentially be easier than in software development, because the variation of the size of the work, the arrival rate, and things like that is different. Which means that if we want to keep our lead times short, how should we think about utilization of our resources in a high variability system? If we want to be responsive to the market. Lower? Yeah, so we need to be lower here before the lead time kicks up and be very long. So if you want to have short time to market in knowledge work or any type of organization where you have high variability, you need to lower the utilization rate of your resources in the organization. But it's still a business decision. It's a strategy you can select. But the lean and agile strategy is to be shorten that. So, how can we then create time for improvements and actually make some space for... So one way is don't actually plan for 100% utilization of people and resources. So what you want to do is to, from your capacity, if you have a theoretical level of 100%, what you want to do is to lower it. So you get to the point where the lead times will not hurt you. So this will actually be your insurance for short lead times. So if short lead times is something that is important for you, time to market, this is one good strategy. Lower the utilization, the planned utilization rate in your organization. But it also creates the options for you to change your mind, because when you have spare capacity in the system that you don't plan for upfront, if something comes along, you can actually change your mind because you have spare capacity. So if something like a very important thing comes up, you can immediately jump into that because you have some spare capacity. And when you also lower the utilization rate, you will handle variation better. And when we can handle the unwanted variation, like different arrival rates or size of the work and things like that, it's easier to plan, and we can actually make better commitments to our clients, which will reduce the amount of yellow bricks in our system. That would be things like rework and handling the customers when they are angry and things like that. But I think the even more important part is that we will create space for actually improving the system. So by lowering the level of utilization, we will create time and space for our organization to spend some time to improve the system. So we can actually raise the capacity of the whole system. So my advice here is try to lower your planned utilization rate. And one number that we use at one of my clients is something like 70%. And in traffic, they say you will see the cars slow down in most highways when the utilization rate approaches something like 67% utilization rate. Then you will see the speed reduce and queues start to form. So do you have more variation in your system than the cars on the highway? To do this, I work with a client right now, and we are trying to do this. And the leaders have been telling the organization, you should not plan for more than 70%. You should spend 30% of your time over the year doing improvements and thinking about doing innovative stuff and try out things and do experimentation. But we have a hard time to get the organization to actually do this. And why? I think it comes down to, you can say something, but if you don't lead by example, the employees will not really see it. It will be like the image in the beginning where the boss goes and pats you on the back. Good work. You have lots of things in progress. I see you are busy. If that is the behavior that the leaders and the managers in the organization has, what they say and what they actually do on a daily basis, then you will not get this change in the organization. So you as a leader has to lead by example. And Jabe, thank you. Took this picture yesterday. So this is the boss. Maybe Jabe. No, he has hair. So what you really want to do is kind of have your employees say, hey, boss, what are you doing? Well, I'm doing improvement work. But you're reading a book. Yes? Whenever something important arrives, I can just close the book and I can start working on that important work immediately. And this way would actually buy lead time in decision making if you're a leader. You are improving yourself, learning more, and you're also leading by example by showing your employees it's good to do improvement work. Something simple like this could really help you. Another thing I want to talk about is that you should actively encourage your organization and build a culture of experimentation. Lean and agile is about doing and trying and exploring the boundaries. So what we really want to do is to run experiments, both on the product and the things that we're trying to do, but also on how we do work. So I highly encourage you to try to create a culture of experimentation. And then you can really see all improvement work that you're doing, you treat them as experiments. So you're in the laboratory, you have the 2 vials, you put them together, what happens? Woo! I didn't expect that. What is that? That is the sound of learning. Sound of new knowledge. Because if we were to pour them together and we would get the result that we expected, okay, we will confirm once again that it worked. There's some value in that. But we didn't really learn something new. So what we need to think about is when we run experiments, what we want to do is to have the unexpected results. Because then we learn, and when we learn, we can change our way of thinking so we can run another experiment and see if we can even take it further. And this is really the scientific method. So we try to start by formulating a hypothesis of how do we think, what will happen when I pour it together? And then we make a prediction. I think this will happen. And this one is really the important part here. If we don't make the prediction, we are losing out. So when I put it together, this will happen. It will be bubbly, bubbly. But then I run the experiment, I actually pull it together, and then we closely observe what happens. And the observation will help us to form a delta between the prediction and the outcome, what really happened. And this is the learning. This is really where we're at. I clicked one too far. So the delta between the prediction and the observed outcome is really the learning that we can formulate. And based on that learning, we can feed into the next cycle of forming a new hypothesis. Did we run the experiment correctly, or is our thinking flawed, or how do we move on? So in another way of thinking, hypothesis, prediction, we aim for something, we get a result, and the delta between what we expected and the outcome is our learning. And this way we have the plus delta, but equally so the minus delta is also learning. So to some degree you could think about this, that you should expect at least 50% of your experiments not to give the expected result. That would be both on the plus side and on the minus side. Because then you can start to explore how is your theory of how your system, and the system in this case would be how you operate work, really works, so you can improve it. And to some degree what you want to do is to not only go for the confirmation side, but you typically want to run experiment that excludes some of your theories, because it's much easier to disprove a hypothesis than actually prove it. And the third thing I want to talk about is to make improvements and changes in small batches. Small batches is good both for making changes and for your system as a whole. So small batches means that we take the big part of work and we make it into smaller pieces. Just like we saw the project A, B, and C in previous slides. If we can break it down to smaller things, it will be easier, both in terms of implementing it, in terms of change, but also when we get things to run through the system in terms of value creation. So what we really want to do is not to put the improvement work in the end of a iteration, in a separate type of meeting or anything like that, or a workshop once a month or once a year. What we really want to do is to put the daily work will be part of this. So we will spend part of the day delivering the actual value, but the other part of the day should be spent on doing improvement to the system. And this will then goes back to the kind of the 70% utilization, planned utilization rate. And you can also think about change. Do you think it's hard to make changes in the organization? Convincing people to try something new could be quite hard. I have a small trick for you. And I'm using this for most of my clients in various explicit or implicit ways. And what you want to do is to kind of start by explaining your hypothesis. So I think if we would try this visualization thing of work, we will be able to understand, and then we could improve our way of working. And if you then make a prediction, so I predict if we start to visualize our work in our work environment, we maybe put up a whiteboard where we visualize the intangible work that we're working on, we will get a better understanding of how things are, so we can start to improve it. Then you actually run the experiment, and you closely observe, and then you should really check to see, did you actually get the result you expected? And then, based on what we saw, we should act. So this is basically the PDCA cycle, or the scientific method. And if we apply that also to how we do changes in our processes and our way of working, it can really help you. By stating things up front, you will reduce the amount of resistance, and you will also state, I typically state, I expect 50% of my experiments to fail. So if we will try this visualization thing, there will probably be problems. So we will have 50% of the time we will not get the expected result. But the thing that I found is, if you, in most organizations, there will be some people that just want to try anything. And you will have a kind of a middle majority that will say, well, depending on how it goes, I can follow along or not. But you will have some people that always will say no. They will not change. And what I found is, if you say, this experiment will run from here to here, and at that point we will evaluate and see what happens. And the shorter you make that time, and give them what I call an I told you so moment, where they can actually say, well, I told you so, this doesn't work, then they are typically willing to try it. And you also lower the resistance for the thinking that they will say, okay, we will change to this strange new way of working, and I will have to do that for the rest of my life. That's a kind of a big commitment. But if I set the commitment to say, okay, we will do these strange things, but saying, I'm working on this, I'm putting that on a post-it note and put it on the wall, and we will only do it for 3 weeks. And if it's too much work and we don't get anything out of it, we will stop. Then they will typically buy into it. And we will have the discussion here if they had the I told you so moment or not. And here, of course, you have to be honest. If we don't get the value, or it's not working, maybe you should not do this. But then you can challenge them. Okay, we had an idea what we wanted to achieve. Do you have another experiment that we can try to see if we can achieve this? Oh, again, kind of leading by example. So you don't get too bought into your own idea of what could actually solve the problem. It's just one experiment. And for me, this has really, really worked. So I will tell you a short story about a support team that I worked with. There were 4 people, and they were kind of supporting a large insurance company's one part of their system, and it was connected to the billing. So there were some flaws in this system. Yes, they built flaw into the system, and this support team had to handle it. And by the 12th of each month, whatever they had in the system at the 12th would be billed out to the customers. And coming up to the 12th, every month, they had a spike, a huge spike of incoming work, of corrections needed to be done. And they were overwhelmed with work, and this kind of spike of work meant, and this was high priority work, because if we didn't change this, the change wouldn't go into the system until the next billing cycle, which was a month further down. So all other work kind of took lower priority, which meant that the things that they were working on before the 12th was pushed off to after the 12th. And typically what happened is that the spike was so big, so they didn't have time all the way through the rest of the month to catch up of the things that they delayed before the 12th. And because they were delayed with the lower priority work, the customers in the organization was calling them all the time. What is happening with my work? This is important work. You need to reprioritize this. And one experiment that we did with this group was is it really so that all the changes come up just before the billing cycle ends? Is that really so? And then we started to ask the stakeholders that were providing them with work, is it so that you actually, this type of work, these changes, do they arrive on the 8th and the 9th every month? Or is it so that they actually arrive during the whole month? And they said, well, they actually arrive more or less evenly out through the whole month, but we know if we give it very close to the 12th, we know it will get the highest priority. So you will do it. So what we did was to then say, okay, we give you a guarantee. If you give it to us 8 days before the deadline, we guarantee it will be done. And everything after that, we will treat it as high priority, but we don't give any guarantees. And just after 2 months, the inflow of work to that organization totally changed. So as soon as something popped up outside and they wanted to change, that came into this organization. And that meant that they had an even and steady flow of work, of support work, which then could lower the amount of things that they had to delay and then handle the complaints from the rest of the organization of things being late. So by simply analyzing the incoming work and running an experiment and see if we could improve the system, we hugely improved the stress level went down, we evened out the flow in the system, and we can even spend some time to do process improvements. So this team went from being like the busy bee company to the Kara company in just 2 months by applying this. So by summarizing, I think you should, to be able to improve and be better all the time, you should plan for less than 100% utilization. And depending on variation in your process, if you're a manufacturing company, maybe it could be a little bit higher than 70%, probably not. If you are in a high variability organization where things are big and small, and the arrival rate is really sporadic, maybe it should be even less than this to be able to handle the variation. and actively encourage people to experiment. And you should expect that at least 50% of the experiment that you run will not give the expected result. And that could be both on the plus delta and on the minus delta side. And make your changes in small batches. So your daily work should be delivering value and improving the way you're working. And do it daily with help. And with that, I will open up for questions. We have time for questions?
Yeah.
Yes.
A few minutes.
And we have coffee, so you can stay how long you want. Now, I will answer one question first. So I built all the Lego slides here, and some of the Lego is borrowed. I borrowed from my son, and he's kind of getting a little bit tired that I borrowed Lego from him. But we have a deal. I buy quite a bit of new Lego, and whenever I'm done doing this Lego stuff, he will get it. But that's 3 years ago when we made that deal. Do we have any questions? Reflections?
So, I have one.
Yes? Do we have a mic?
Yes. So, nice, but
Thank you.
this idea of utilization not at 100% is in general incompatible with the current way of thinking and operating, especially in Italy, where especially knowledge work, we're used to load people at 120% maybe. Maybe just if we know that they only will do 80%, but just give them 120. Like the spike in the last days of the month.
Yeah. So do you think it's working for you?
Well, unfortunately, no. That's not it. But still, the biggest, the typical reaction is, no, we cannot do that.
Yes.
That's impossible. We cannot afford to do that. And doing it in small chunks, well, difficult.
Yeah. So I think the key here is when I say the plan for utilization for 70%, you have to plan low priority work into the other 30%. So typically you need to say, we are doing something in the 70% here. And maybe you should have a kind of a backlog of improvement work, reading cycles, kind of book circles and things like that. You need to schedule something in there, because otherwise kind of the theory X type of managers in the organization will be very scared. But you can also kind of say, okay, we will not make this change for the whole company at once. We will just try it with this small unit here on the side. And we will run an experiment. And we expect this result to be, is the prediction. And we will run it for this amount of time. Are you willing to make us do this? I have the I told you so moment that if it doesn't work, we can switch back. And it's the worst thing that can happen if we do it for a small unit and a small part of the company for a limited amount of time. The worst thing that could happen is that we will lose those 30% for that amount of time. That's the worst thing that could happen. Are you willing to bet that? Is that a question, answer to your question?
Yeah.
I'm not sure if it's not.
Yeah.
Yeah, good.
Just coming back to this problem regarding how to let people spend this time for improvement,
Yep.
10%, 100%, whatever. Maybe this kind of technique of sitting, that the boss is sitting in the team room, the book reading and trying to improve the process. I mean, this can be for sure something that can go in the right direction, but in my experience it didn't work. Or at least it was not enough. Do you have, since it's something related to the people culture or company culture, do you have some more advices for boosting this kind of attitude?
So It's hard. It is really hard. The company I work for, we have tried this for 9 months now, from when the head of the department said, this is how we're going to run. Not that much has happened. But we're trying to do it. And I think the key is to schedule in low priority work and kind of fill up this part here. But you know it's low priority work. So whenever high priority work arrives, you can switch to the high priority work. And the other key is really to think like this. Don't put in a day of the week or 2 days in a month or something like that. Make it small. Make the first thing. One of the companies that I actually had this to work was to say, okay, we will spend 10 minutes after lunch each day, and the first goal of the time we spend there is to try to see if we can get 10 more minutes of free time the next week. And when we had 10 minutes of extra 10 minutes of free time, we took 5 minutes of that and put it back into the system and 5 minutes into improvement. So then we had 15 minutes. And then we grew it eventually so we had half an hour every day that we consciously spent on doing improvement work. But we still had the same capacity out of the system in terms of number of features that the team delivered. But if you take a big change and there will be a stop for 1 day, people start to get worried. We have one more question here. Last one. I will run. It's not working?
The time for the improving, and also what we target to try to experiment, the experiments that you want, is something that is come from your personal feeling, but also I think is agreed with your the object of the company, or of the company. So it's something that you want to experiment because it is can bring benefit for the company. The question is it possible that this time became delivery time because we have agreed with the objective with the company? I don't know if I...
So if I understood your question right, by doing the improvement time, by improving, we put it into actually being more production time. Was that the question? So to some degree, that is the goal, right? We want to raise the capacity over time. But when you start out and you don't have any time for improvements, you could then say, you make a kind of a deal that you say, whenever I free 10 minutes, I will give 5 minutes back to raising the capacity, and 5 minutes I keep for improvement. And in that way, you kind of you give back as soon as possible, and that way you kind of lower the resistance of actually giving the time for improvement. Did that answer your question? Do we have time for more questions, or do we break for coffee?
No.
Break for coffee, or it will be panic.
Go,